Now see the second question. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of other chord. Now this is wrong. Okay, see this figure. In this figure, this is a circle with center O. Okay, AB and CD are two chords of the circle and they intersect within the circle. Okay, and these two chords are equal also, that is AB is equals to CD. We have to prove their corresponding parts are equal. That means we have to prove AE is equals to ED and CE is equals to EB. Okay, what we have to prove? AE is equals to ED and CE is equals to B. Okay, so first of all you will write this what is given to us, then you will write to prove, then we will write the construction. In construction what we have done? We have drawn OM perpendicular to AB, okay, and ON perpendicular to CD, and we have joined OE. Okay, now let's see the proof. In right triangle OME and ONE, okay, that means in these two triangles, first of all OE is equals to OE. This OE is common, so OE is equals to OE common, and then OM is equals to ON. Why? Because these two chords are equal, and we have studied the theorem that equal chords are equidistant from the center. Okay, so OM is equals to ON, and reason is equal chords are equidistant from the center. Okay, and since in construction we have drawn this perpendicular, so this angle will be equal to 90 degree. So we can write angle OME is equals to angle ONE, each 90 degree. Okay, now this is right angle, this is hypotenuse, and this is side. So by RHS congruency, triangle OME is congruent to triangle ONE. Okay, now if these two triangles are congruent, their corresponding parts will also be equal. So ME is equals to NE by CPCT. Name this as equation number 1. Okay, now in question it is given that both the chords are equal. So AB is equals to CD, so their half will also be equal. So half of AB will be equal to half of CD. Okay, now one more theorem we have studied. Perpendicular from the center bisects the chord. This is the perpendicular and this will bisect the chord. This is also perpendicular and this will also bisect the chord. That means these two parts will be equal and these two parts will be equal. Okay, so half of AB will be equals to AM. Half of this AB will be equal to this AM. Okay, and half of CD will be equal to this ND. Okay, so instead of half of CD we will write ND. Now name this as equation number 2. Reason will be our theorem perpendicular from the center bisects the chord. Okay, now we will add equation number 1 and 2. So adding equation number 1 and 2. ME plus AM is equals to NE plus ND. Now ME plus AM is equals to this full AE. Okay, so in LHS what will come? AE, then is equals to NE plus ND. That means this full will come, so this will be equals to ED. So AE is equals to ED. Name this as equation number 3. This is the first part of our solution. Okay, Now again we know that both the chords are equal, so AB is equals to CD. Name this as equation number 4. Now what we will do, we will subtract equation number 3 from equation number 4. So AB minus AE is equals to CD minus ED. Okay, now see AB minus AE. This is AB and minus AE. When we will subtract this part from AB, only this part will be left. That means our LHS will be equals to EB. Okay, so here what will come, EB or BE, anything you can write. Then is equals to CD minus ED. Now see, this is CD, then minus ED. When we will subtract ED from CD, this part will be left, that is CE. So in right hand side what will come, CE. Okay, so this is the second part of our solution. So we got the answer and we can write hence proved. Thank you everyone. If you like my videos, please like, subscribe and share my channel, and stay connected with A1 study classes.